Hello, everyone. This is Eric Lee again. Um, Wanted to make this video about physics, as I usually try to do. And um, yeah, sorry about all the clutter on my table. It's actually kind of neat compared to the way it is most of the time. And there's a lot of like binoculars and um, tools to fix the binoculars and whatnot. I'm not an oculist, by the way. That's some kind of interesting organization that supposedly exists, but you know, I'm not any part of any society like that. I was part of a group called SIS, Society on Interdisciplinary Studies, based in the United Kingdom, and they studied catastrophism, and they studied all manner of different, um, what do you call it, different areas of scientific study to, um, I guess, piece together, like, you know, um, the subject of catastrophism, what could happen to our universe, but more mainly like what could happen on the earth. But anyway, I'm going off completely on a different thing. Um, just trying to give you a little background um, of some things I did in the past. But anyway, this video um, is going to be, um, I'm going to entitle it The Source of Light and the Propagation Thereof, and the nature of a photon. And as you know, like Einstein, he got his Nobel Prize through his paper, The Properties of Photoelectric Aspects, or something. I can't remember the title, but it was a photoelectric principles of a photon, I believe, is what something like that. And he was explaining, the nature of light and what a photon is. But believe it or not, although he won the Nobel Prize on that, um, there are a lot of physicists and just scientists and even philosophers in general that say, well, there's really no such thing as a photon. Some people say, well, light is both a quantifiable photon, I'm sorry, not proton, photon, as well as a wave. And, uh, you know, before I was going to make this video, I wanted to kind of make sure that I didn't just dive into it like I normally do without, like, searching up material to make sure that nobody's ever touched on, not well, I shouldn't say touched on the subject, but basically explained it already, or, you know, what would you say, solve the whole issue, and I'm just kind of arriving very late and saying, well, hey, but anyway, I looked it up on Google, and it was very interesting. As it turns out, the fact that, you know, like the physicists, when they say like photons, like what are they and how do you measure them and all these things, there's no clear answer. And uh, the conclusion of this video, which I'll get to hopefully, I don't know, not too convoluted of too long of a too long of a time. Uh, um, anyway, let me just get to the point. It just I tend to get long winded, and I keep thinking about like, gee, I'm gonna like say things, and I get caught up with my own words, and I do apologize for that. That's just I don't know. I don't normally speak like this. I'm pretty concise and just to the point, but this is just something I don't want to screw up on or mess up, and um, I'm trying to pick my words wisely here. But anyway, I looked it up on Google, and there were some interesting like tidbits on there, and people trying to explain what a photon was. Like one thing that came to mind was that comes to mind is it showed like the light wave, that goes like this, and you know, and light travels in waves. We know that, and the the quantifying of a photon, like nobody can define really how or what part of the light wave you are measuring to say, well, that's the photon, and I'll show you. Like, okay, so you're taking like one uh, wavelength of light here, and like the one picture I saw on Google was like they circled this part here, the peak of the waveform of light, and it has this little arrow, and there's like this measurement right here is the quantifiable measurement of the photon, right? I'm trying to look through this camera lens on my phone, and with a screen, I should say. I'm trying to write. It's kind of hard to do. It's weird. But, and is that really the photon? No, it's not. It's just you're measuring um, one of the peaks of a ripple, or you could say the waveform. Um, one strand of it, or you could say like what's the proper terminology? Just one waveform of it, or one string of it, or whatever you want to call it. But if we looked at it from the top, it would literally look like a ripple, like this, from the source of light. And of course, it would be 3D, and it would travel out from, I guess, like an atom, and it would travel out like a 3D globe, a sphere. And I've been saying that through my videos. Like, people tend to see things in like a one-dimensional aspect, or well, not one-dimensional, two-dimensional aspect, and they kind of like jumble themselves up because they're seeing it in like a totally wrong perspective. And this is another example right here. This is not how light propagates. It propagates as a sphere, and it propagates in a waveform. So, and how does that happen? Well, before I go on further, I just want to quote like one of my favorite, rock legends. And his, it was Jim Morrison from The Doors. And if he says, he says, if the doors of perception were cleansed, everything would appear to man as it is, infinite. And that really is so like deep and poetic. The guy obviously was a creative genius. He was a poet, um, you know, uh, one of the most interesting singers of his time, and he, of course, met an early demise. Maybe I'll make some kind of interesting video about that in the future. I don't know. But anyway, just love the Doors, and that was just a really interesting thing that he said. And I'll explain how that correlates to what I'm trying to tell you. What the source of light and the propagation, um, how it propagates, and um, good grief, I hate the way I speak when I'm on this video. Basically, what is a photon? Do they really exist? Are they quantifiable? It's interesting. Well, anyway, like I said, I looked it up on Google, and there were like all these weird explanations for what a photon is or could be, how you measure them, and none of them were really right. Um, and I I saw this one video, I think a while back, or at least a part of it, and I didn't watch the whole thing through. But this interesting man, I'll post it on my Pinterest. By the way, my Pinterest is called Eric Lee, the rubbish writer. It's all one phrase connected, and it's under the heading time. My discussion about physics, and basically it started off just trying to describe what time was, but it turned into other things. But um, it's all interrelated, as you know. But anyway, yeah. So um, I was looking at all these videos, and okay, that was my daughter, uh, Rebecca, and you know, she actually was accepted to university recently, and she's going for geology now. Um, I originally thought she was going to do chemistry, but she decided to switch to geology, which is very interesting. And my future videos, I'm going to make some things interesting about geology too. But anyway, I go off on these weird tangents. But anyway, um, what was I saying? Good grief. This is maybe I should scrub this video, or maybe not. I don't know. But anyway, okay, we're 12 minutes into it. Okay, continue. So, okay, so let me pause it. Okay, so my daughter just totally interrupted my train of thought there. So I was saying that I ran into this video, and it was made by this. Excuse me. It was made by this physicist, and I'm pretty sure he has a PhD. And he was explaining how his view on photons and light and everything, it's completely changed since excuse me. Oh my goodness. Okay, I'm back. I just started coughing, and I thought this was going to be a smooth video to somewhat uh, of a degree, but good grief, I'm getting interrupted like anyway, where was I? Yeah, this guy, he made this video, and he was trying to find out how he could measure um, a photon, and I guess manipulate, like, the different, like, trying to do the double blind split experiment, uh, or double split blind. I'm sorry. And he he set up this elaborate, like, you know um, setup to completely delay one emitter of electron um, beam to compared to the other one. And it's so many physicists have tried this to try and measure or get different results than the interference pattern you always end up getting. And I was kind of chuckling through the whole video as I watched, most of it. I think I watched like 98% of it. And, you know, uh, I was chuckling because I already knew what was going to happen, and basically the conclusion was, well, you cannot quantify exactly what a photon is. Um, and the only way that you do quantify it is by saying, like, well, okay, he gives an example of like a CCD sensor, like in a camera, digital camera, and you have all the pixels in the sensor, right? And you have like one little tiny, out of, like, if you have a 50 megapixel sensor, then that's like one of the 50 million pixels, and you get a measurement in there of you can say, well, that's the measurement of the photon. Well, is it? Well, of course it's not. You're quantifying it in that one pixel. That's all you're doing. And then he shows at the end of, like, the interference. He said he just ended up with the same interference pattern, like, that line of particles that I showed you in like another video I did, and it was one of my earlier videos, and I was saying like how virtual particles could be formed from energy that was shot through the split blind test. And interestingly, there was, well, I'm getting off topic again, I'm sorry. There was another, like, person, another physicist with a PhD trying to explain it, saying if you send a beam of light into a very thin lead plate, you get two virtual particles, the electron and a oh, good grief, the positive version of it. Is it the photons? Is it wait a minute? Oh my goodness! Electron, and then you get the proton, or, oh my gosh, this is really, I can't remember that. But okay, I'm gonna continue on. Did this? I totally forgot the name of that particle, and then they come back together, and then they annihilate, and it goes back to the sea of particles that I told you guys about, which is the infinitely small particles, because we live in a medium. And anyway, before I get to all that, the experiment that I was originally on, I know I'm totally confusing tonight. I like I said, I do not prepare for these videos. I just have this, like, moment of, I don't know, like this muse comes to me, or I just get this crazy desire to make this type of thing, and it just happens. Anyway, um, um, he gets this interference pattern in this one video. I just completely, like, came off of topic on, and he shows like a closer view of, like, these really small particles that he magnifies, and he says, well, is this uh, the quantified, like, photon particle, or is this the quantified? And they all look similar in shape, but they have obvious, like, different, like, shapes, or different, like, amounts of saturation. Um, so he's like, well, no, there's really no way to measure photons, and to define clearly what a photon even really is. And so this is what I want to clear up, and hopefully I'll be able to do this. And geez, it took me 20 minutes to explain what I was going to really do. So anyway, forgive my just my convoluted ways of like speaking and all these tangents I go into and interruptions I get. Anyway, and one of the people that commented on this video is like, this person was really smart. She said, a photon is exactly as big as it needs to be unless you try to measure it, then it's exactly the wrong size. So how can that be, right? Like you're asking yourself, how can that be? So, okay, like, um, the interesting that I was gonna do, you know, another version of this video, what I was gonna do is I was gonna go up to some blinds and I was gonna like, let me see if I can do this, show you part of my room here. To blinds, I was gonna like go woo 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 woo, and actually you can kind of see the action right now. You can see like the outside, through the through the blinds, and if it was daylight, you would start seeing more of the light coming through. So, um, you know, what's happening with light? Where's the source of light? How does it propagate? And this was, you know, this was what I was going to show you. So, or this is what I'm going to show you. So, basically, okay, what another one of the things that was on Google, when I looked up the subject was, one of these physicists said, when an electron in an atom gets very excited and it drops down a level of excitation, because like there's like different like electron orbits around the proton and the neutron, right? Um, uh, uh, I'm getting like jumped because I'm thinking of the word that I tried to say earlier. The electron versus the proton. Anyway, okay, we're past that. Never mind. So you have the, you have the neutron and the proton, right? And then you have the electron, and usually the orbit of, like, let's say this is hydrogen atom with just one electron, and it just circles around here. But then what he said was when it gets excited, um, um, uh, what did he say? The electron will actually, oh, the electron will actually come down in orbit, to one energy level down, and that's when light is emitted from the electron. So I'm like, well, is that really what's going on? And I said, no. If you understand the nature of this, the sea of particles that I've been trying to describe makes up our unseen universe. What's really happening is, okay, like, let's look at it like, um, I mean, what would you say? It's sort of kind of right in certain ways, but let me go a little deeper. I mean, it's like, okay, let's say this is the neutron, this is the uh, uh, proton, and then you've got like, okay, forget this picture over here. And then you've got like this like electron that's going around in circles, right? Or that's the accepted idea. um, I mean, nobody really knows what an electron looks like. Nobody knows what a proton, or a nucleus of an atom really looks like. These are all just, again, quantified, ideas, conceptualizations. So sometimes, like, you'll see, like, um, this fuzzy ball, which is represents an atom, and you'll see, like the electrons are depicted as like these energy rings that go around it, and they're like kind of vibrating in this weird, like, kind of like an onion ring going around the sphere. And maybe it's just um, a, a shell. Um, Obviously, it's some kind of a shell that's formed through some kind of resonant vibrational frequency of energy there. Um, you know, or it could be, yeah, it could be that the accepted belief that the electron travels so fast around the entire nucleus that it just seems like a fuzzy shell, because that's what you see is a fuzzy little ball. Um, but anyway, going back to the source of light, um, it's not the electrons that actually, um, in my opinion, that are causing the source of light. What's happening is, whether you believe in the the onion, the vibrating onion ring that's like a field that is around the whole structure of the nucleus, um, or whether you believe it's a ball that's whizzing around. Some people don't even believe electrons even exist, or some people say it's one electron going around a whole bunch of, like, if you have a slab of metal, it's only one electron there, and it's going around the entire, like, the nucleus of every nucleus that exists there. I mean, that's kind of a, like, I don't believe that. That doesn't make any sense, not to me anyway. I mean, it could be true, I don't know, but I don't think that's the case. I think it's either more like this kind of like field of energy that's around these atoms, or it could be an actual particle that just, like, whizzing around at extremely, well, light speed, right? So anyway, what happens is, yeah, when I do agree that when an electron, okay, let me give you an example. Okay, when you rub two sticks together, okay, you're compressing the electron down, um, not only through compression, but the heat that you're creating would literally make this electron, in theory, um, spin faster. And why? And when it spins faster, obviously, you would get a reduction of the radius. And the radius is the measurement of, simple geometry, is the center of the nucleus of the atom to the outside. So this would reduce, because when it speeds up, obviously, if you increase the circumference or increase the radius, then it'll spin slower. So as it speeds up, it's going to come closer to the nucleus. And what's happening is, you've heard the saying that there's more spaces in between the parts of the atoms than there are actual particles. Well, that is a key in itself, and you must ask yourself, what is in those spaces? And I've already explained that gravity works by these very, very small particles, ISP as I call them. They're constantly going through the makeup of any mass, any material, and um, through various actions that I described, that which I'm not going to repeat the whole process. Um, through the act of distortion and compression. That's pretty simple enough explanation, yeah. That's what I'm looking for. Compression, distortion. Basically, they're being squeezed together, and this energy, um, these ISP particles, are trying to condense and squeeze everything to the core of the Earth. And I explained this through this conceptual drawing that I did of like how gravity is behaving with this energy that is going towards the core of the planet, of any like spherical object or any object really with any mass. But anyway, okay, going back to the source of light. Well, okay, so when this electron starts compressing down here and it starts spinning faster, well, what are you doing? You're actually taking these like tiny, infinitely small particles, as I described them before, and you're squeezing them together. So when you squeeze them together, you're basically like creating a dynamo, something that produces uh, energy. Sort of like you could like say it's like a, I what was it, when I was talking about the universal fine constant, there's like 1/140, right? And then like for combustion to take place in a cylinder of an engine, it's like you have one particle of fuel versus like 14, or more accurately 13.8, I think, is a stoichiometric pressure. But anyway, uh, this compresses all these particles in here, and um, I guess you could say it kind of compresses them and traps them to the point where there's a pushback. It literally uh, squeezes all this like infinitely small particles together for I don't know how many nanoseconds, or I don't know, that aspect of it. But then there's a rebound, because you can only squeeze it so far before there's a counter reaction. And this counter reaction creates a waveform of light, as we deem it to be. What we term it as light, um, and it creates basically like a shock wave, and the shock wave propagates, as I said, like a sphere, and it's much like this type of energy on the quantum scale coming back out from the core, which would be in the nucleus, and it radiates out, and that's how light is propagating from any source. And you could say, well, what about lasers? You have just a beam of light, but do you really just have really a beam of light? No, you see reflections of it everywhere. So you're creating like a toroidal. I described this before. It's like this is the laser beam, and then you're going to have like these circles going around it, which are it's like some physicists call it like a ring of electrons that propagate the light in waves out from this, or else we wouldn't be able to even see the laser, right? I mean, so these light waves are coming out, but the amplitude of this, the light wave causes a field, and pushes out more particles as the light travels through this medium, and then you get the light waves coming at you from the sides too. But yeah, the most of the amplitude of the signal, or the light I should say, goes this way, and then it when it hits whatever target, you know it's gonna really like heat it up or burn it up or whatever. But uh, uh, light just it's very interesting. I mean, you have this toroidal, almost like a magnetic field forming around this light, and then from here you get again like ripples coming towards you, uh, and it's because of this medium that we live in. It's like what are you saying? Like it's sort of like being inside like a you could say a carnival room of mirrors. You could say in a way, because whenever you create a perturbance, when you whenever you have like a perturbation a perturbation in this medium, it just creates this, waves of light. And it starts from, um, the this the medium, which is inside the atom. And you can see this type of thing not only when you rub two sticks together and you compress this, when just heat like a metal bar up, it starts to glow red hot. This steel bar, let's say, and right before it starts glowing red hot, this is the action that takes place through the heating up of the metal or whatever material you want to consider. You end up compressing this energy which exists within the what they call, they say there's more empty space, but it's really not empty, as I'm trying to explain to you right now. That's the whole point of like what I'm trying to say. The source of light is not the electron. Oh, they interact with each other. This, I've called it even the possible candidate for dark matter, and all dark matters is like infinitely small particles that we can't detect with current sensors, but we can see the indirect effects of it. Like this, like I said before, like this spin of galaxies are not like what the calculations say it should be. And like, physicists have noticed like we're not seeing 80% or 70 something percent of what's really out there in the cosmos. And really, it's interesting what amount of the light spectrum as human beings that we can see is. It's actually something like what was it? It's like 0.00. Was it 3 zeros or 2 zeros? You can fact check. You should fact check me on this one, but I think it's like 32.00032% of the light spectrum we can actually perceive with our human eyes. So that's pretty bad. I mean, we think we can see like, everything that's in existence with our eyes, but we only see that little bit of what is reality. That just kind of is mind-boggling, really. Um, and the arrogance of us to think that, oh, our eyes do not deceive us. Our eyes definitely do deceive us, and it's really, really very interesting. And you know, when the this lady or young lady or this person, she says about the photon. Again, I'll quote her: "A photon is exactly as big as it needs to be, unless you try to measure it. Then it's exactly the wrong size." So, going back to this again, I thought this was going to be kind of easy, but it never is. Trying to explain all the intricacies or the big picture of what's really happening here. So where was I at? Good grief. I'm such a nutcase. It's like I totally lose my train of thought. Excuse me for that. Yeah, so we were here, and so going back to like, what is a photon? Is like, we really have to see it three-dimensionally, and it propagates as a three-dimensional sphere. And even when you try to use it like to concentrate it into like a beam as like in a laser, it's still really not. You're just focusing it, you're attenuating it, and then you're concentrating it, and you um, you know increase the amplitude of it, and then you blast something. You get the idea. It just you know basically the reason why we can't quantify you know light into just a photon, and say that really photons exist in the way that we'd like, is because I guess the grand ending to this video would be that you're trying to quantify something that is as big as an ocean, something that's infinite, like Jim Morrison just said. He in his documentary, it's called "People Are Strange," and Johnny Depp, like he is the narrator of this documentary. Very interesting documentary, by the way. Um, he says Jim Morrison says something really interesting too. Like he says, like these days, um, uh, the way to become famous is uh, this isn't verbatim, by the way. He says these days the way you become famous is to become an assassin, and I'm just like, what? But I don't know. There's some kind of weird meaning to everything he says, but anyway, it just or he says these days you aren't somebody unless you're an assassin or something. I can't remember now. Oh my goodness. Never mind. Anyway, anyway, maybe he was trying to describe like the cutthroat nature of like how people are becoming in the modern age. And, plenty of good people out there. I mean, especially the town I live in right now. Lovely people. I love this place. Wish I would have like grown up here all my life, but lived in other parts of towns where like in other towns there were like just people you just even and when you try to get along with them, they just want to kind of do horrible things to you. Anyway, that's a whole different topic. um and yeah, I'm so scatterbrained today. um Geez, but I don't even know if I should even publish this video. It's so crazy. But anyway, they had like different diagrams, like like these circles of light propagation, and it's like I'll just post a video. He explains it way better than I do. He's a better speaker. I'm horrible tonight. I'm just everywhere and almost nowhere. But I think I hope I kind of made my point here as to the source of light. It's actually the shock wave of the squeezing the infinitely small particles together, and then when it releases, and you get like a expansion of the electrons, right? And the material tends to expand and gets kind of like even the makeup of like, let's say like steel it starts to get bendy and stretchy, and I don't know. But anyway, that's just something, another phenomenon. But I'm just trying to talk about when it starts emitting light. You know, um, you know, the electrons have compressed and just in an instant they compress and they just go boop like this, and it just sends out ripples. You know, and these ripples are, of course, these light waves that come out. There's, in all different 3D spherical dimensions from the inside of the atom. And so there you go. That's the source of light, and the propagation is by wavelengths or through waves. Light travels as waves. And let me mention one more interesting person. His name is Ken, and he is an expert on this. And you can look at some of his videos. And he has this site called Theoria Apophysis. I think I said that right. He really talks a lot about like electromagnetism. He talks about light. A very interesting person, really, really smart. I don't know if he has any. He says he doesn't have any religious belief, I believe, and he he's not a. He says he doesn't cater to particle physics. That's what he says. So I was like curious when he said that. So he's like in the school of like Nikola Tesla, who called, Einstein a fuzzy-haired crackpot because he said, Nikola Tesla, the guy was a genius. He discovered alternating current. Um, so he knew what he was talking about. I think, like people like that, um, they know what they're talking about in their speciality. And Nikola Tesla, he said, quantum physics, um, even relativity, the atomists, people who believed in particles, quantum particles. He said they were all crackpots. He believed in this like giant universe of, I guess, sort of what I'm talking about. But I, think that Tesla and, interesting people that think in terms of that reasoning is, it's not that they're wrong. They're seeing an intense like spectrum of one wavelength of the whole big picture. And me, I'm trying to like um, unify all of that. And I made a bold claim that if you look at everything that I'm saying here, it does unify, um, all the different effects you see around you. And it's my theory, I call it, let me see if I get it right, the multiverse leak down emergence theory. And as I said before, it can stand on its own in a static type universe with multiverses where particles are emerging um, um, from like another um, dimensional reality. And another dimensional reality, I get into what is in a dimensional reality, which is like when you have um, particles that we cannot perceive. It doesn't fit into our perception of time. It's on a whole different reality level, but it's there, and things emerge out of it or leak into our universe, you could say, whatever way you want to look at it. I initially said that it was leaking into our universe, but it's really emerging. Well, it's the same thing, right? Anyway, and then I said it could also work with the Big Bang Theory, you know, and the Big Bang Theory makes a lot of sense too. So whichever way you want to look at it, it's that's totally up to you. I'm just trying to present the facts, or at least, well, I can't say they're facts, but um, what really makes sense, I should say, scientific sense. And by the way, oh, one more thing, the the it's NASA. They're gonna launch 3 rockets into the solar eclipse totality, and the reason why they're launching 3 rockets, and it's gonna do some sort of explosion in the cosmos, in space, or maybe even in the air. I don't know. But these are to study um, um, the nature or existence of dark matter, which is extremely interesting. Maybe, well, I would like to think that, people are listening to what I'm saying. I don't get much views on YouTube, but when I put these things on Pinterest, there's a lot, I'm getting a lot of like what they call impressions. And I really don't even know what they are, what impressions even really mean. I just put it out there and it seems pretty popular. So I don't know. Anyway, hopefully, I'm making some sort of important contribution in a small way, or maybe even a big way. I don't know. It doesn't matter. I'm doing it freely. Um, uh, and hopefully, I've covered everything. um, Let me pause it for 1 second to make sure I didn't miss something here. Hold on. Yeah, so I paused the video to make sure I covered all the bases. My mind is completely blank right now. uh, I I'm sorry if I was just like everywhere, in this video tonight. I try to make it as coherent as possible. I have so many thoughts like racing through my mind. Um, and then I just really get nervous when I'm like speaking publicly, or I completely failed my speech classes. I refuse to make any speeches. And I failed on my science projects, by the way, when I was in middle school. um, because I would make the project, and then I was so like horrified of standing in front of people to speak in front of them, that I rather took the failure mark than to have the courage to go up there and speak in front of people and make a speech. So yeah, that's why I'm so nervous and just everywhere sometimes with that. And very very interesting um, life I've had. I'll talk more about, like, I guess my family. As I said, we've got some really interesting things that happen as an immigrant family in this country. Um, what else? I could do, so many videos about that. Very interesting aspects of that. Um, uh, anyway, I'll just leave it at that. And thank you for listening to my crazy helter skelter everywhere video today. I'm just going to leave it as it is. I never go back to listen to what I said before, because I'm one of these people that can't stand listening to their own voice or their own videos, like, or recordings that they make. So I don't go back and listen to them if I can help it. And this is like one of those like horrific ones. So I don't even want to hear myself and how stupid I sound on this one. So anyway, hopefully you kind of got what I was saying with this, though. I was hoping this would be my Hmm. Uh, I don't know, my masterpiece. Oh my goodness. Anyway, have a good week, and hopefully my next video won't be so crazy like this. I will make a few more that touch on some interesting things. Um, but yeah, this is about where I'm going to end it. Thank you for listening to my craziness. Okay, bye bye.